Creatine doesn't make you stronger in one way. It makes you stronger through four distinct mechanisms, operating through different biological pathways and across different timescales. Understanding each separately is what makes the research findings coherent, and what explains why creatine's strength benefits appear so consistently across different populations and sports. The first mechanism is the most immediate: phosphocreatine expansion. More creatine in your muscles means more phosphocreatine available during the most intense phase of a lift. When you're working at 90 to 100% of your 1 rep max, the phosphocreatine system is the primary energy source for the first several seconds of effort. A larger phosphocreatine reservoir means you can sustain that maximal intensity slightly longer before the system runs low and force output drops. Practically, this is a rep or two more on your heaviest sets. And it's exactly those final reps, performed at maximum effort, that provide the strongest stimulus for strength adaptation. The second mechanism operates across an entire training session: volume amplification. Creatine's phosphocreatine benefit applies to every set, not just one. Faster phosphocreatine recovery between sets means the second, third, and fourth sets of an exercise begin with more fuel than they would without supplementation. Over a full session, the cumulative effect is meaningfully higher total training volume, more reps at a given weight or the same reps at a slightly higher weight. This volume increase, sustained across weeks and months, produces a larger cumulative strength training stimulus. The strength that results is real and structural. It comes from superior training quality over time, not from a pharmacological effect in the moment. The third mechanism is satellite cell activation. Satellite cells are muscle stem cells that contribute to repair and growth after training. Creatine supplementation increases satellite cell activity independently of training and more substantially when combined with training. More active satellite cells mean more muscle nuclear content, the nuclei that govern protein synthesis capacity within each fiber. Muscle fibers with more nuclei can support more protein synthesis, which directly supports larger, stronger tissue. This mechanism operates over weeks and months and explains part of why long-term strength gains from creatine exceed what you'd predict from the phosphocreatine mechanism alone. The fourth mechanism is the most important for total long-term outcomes: training quality compounding. Every percentage improvement in performance per session, multiplied across every session in a training block, multiplied across months and years, results in a substantially different strength ceiling than training without creatine would produce. Studies tracking long-term creatine users show strength differences between supplemented and unsupplemented training groups that compound considerably over time. Differences that reflect the accumulated training quality gap, not an ongoing pharmacological effect. There is also evidence for a fifth contribution that's less mechanistically clean: neuromuscular adaptation. Some research suggests creatine supplementation modestly improves motor unit recruitment patterns and rate coding, the speed at which the nervous system signals muscles to contract. The mechanism here is not fully characterized, but it may relate to improved neural energy metabolism or changes in neural firing under metabolic stress. If this effect is causal rather than correlational, it would contribute to strength through improved neural drive rather than through energy system or structural mechanisms. The full picture: phosphocreatine expansion for immediate intensity, volume amplification for session-level gains, satellite cell activation for structural growth, training compounding for long-term outcomes. That's the complete mechanistic case for why creatine is the most consistently effective legal supplement for strength development across virtually every population studied. There's a practical synthesis from understanding all four mechanisms. The strength gained from creatine is not a fragile, supplement-dependent performance that disappears when you stop. The additional training volume accumulated while supplementing, the extra reps, the extra sets, the marginally higher quality of every session over months and years, represents real structural adaptation. Myosin-heavy chains, actin filaments, satellite cell-contributed nuclei. These structural changes persist long after you stop supplementing because they were built by training, not by the creatine itself. The creatine made the training better. The training made the muscle. Stop creatine and the performance edge softens over 4 to 6 weeks as stores deplete.